Hello, everyone. So this is another MATHCOUNTS team round question. So it was a state level, number 8. Okay. So we have a like quadrilateral, okay, A, P, B, Q, and we have A, B, and two vertices are given, and we are given this equation, okay, the line of this equation, which is 4x plus 3y, and we also know the PQ, which is this guy, is 3, so we are looking for the area of this region. So you can do this question a couple of ways, like, but the first things first, we want to find the area of this triangle plus this triangle. So the first thing you can probably try, like plugging, finding the altitude. So, if you kind of know this is your altitude, maybe it's somewhere right here, which is not really obvious. Maybe this is the altitude, but let's say this is my altitude for this triangle. And but for the other triangle, this guy is a fifth angle, so the height will be outside. So it will be something like this. If you were to extend this segment, this line, so your altitude will be outside. So you could say this is my, let's say H1, and this is 90 degrees, this is H2. So since we know the PQ as 3, so if you know this like height, the H1, you may find the area of this triangle. And then if you can find the H2, you may find the area of this triangle as well. So you can combine those. That is something you can do for sure. But to do so, you may use the equation that you are given and then the points that's given to find some relation, because we already know, like, if I want to like find this point, which is my x-intercept of the line, I can plug 0 and then I will get x as 19/4 for this point, which means I do have a triangle right here and I do know the height. Okay. And then also we know y-intercept, so I can plug 0 for x and I can get y as 19/3, which will be this segment. So I have the two sides of this right triangle. And also, like, you could use the like Pythagorean to find the hypotenuse, but maybe better than that, you may like find the slope of this equation, which is gonna be like, if I leave like y alone, so if you subtract 4x from both sides, so you will get 3y is just minus 4x plus 19. And then divide by 3, you will get negative 4/3, which means the ratio of this divided by this is 4 to 3, which is a 3, 4, 5 triangle. So you can see that relation immediately. Since we know the lengths, we can find the hypotenuse by just using that 3, 4, 5. Okay. But anyway, so that is something you can do. And then you can just use the similar triangles, because the angle right here, same as this guy. And this angle will be same as this guy, because the angle of this guy and this guy add up to 90. So this guy and this guy is add up to 90, which means this angle right here has to be same as this one. So from here, so you can see a lot of similar triangles going on. So you can write the ratios and find the heights of those two triangles, and that will give us the answer to to area of those two triangles. That is something you can try. I will leave that for you. But for this video, I'm gonna actually remind, or just kind of ask you to like kind of remember another approach. Okay, so whenever you have a point, and then if you have a line, let's assume we have something. Let's say this is a line, and if you wanna find a point, and then this is between a point with that given line, the shortest distance, I would say. Like, you can have like segment like this, segment like this, you can have segment like that. But the shortest one that you can have is gonna be the one that will be perpendicular. Okay. And that will be perpendicular. I'm gonna call this is D, that's the distance. So if this is x1, y1 as my coordinate, and then if I call the equation of this line is ax plus by plus c is equal to 0. So to find the shortest distance, we have actually nice, I would say, formula, but you may try proving that as well. Maybe I will prove that at some point later. But that is the shortest distance between a point and a line. Okay, so you plug the the coordinates into the equation you are given. So instead of x and y, so that will be a times x1 and b times like y1 plus c. Sometimes this value will be a negative based on the number that we have, but the distance cannot be negative, so which is why we will take the absolute value of this quantity, and we are going to divide this whole thing by the square root of the square of the coefficient of the x and y. So you square a and you square b, and if you take the square root of that sum, and this is gonna give us the distance between this point and this line. So why this is important? Because it looks like a bit challenging looking, but at the same time you just take the point that you are given and plug into the given equation for x and y, and take the square root of square of the coefficient of the x and y, which looks like the Pythagorean except the c. So this is kind of same as that one, so you can maybe remember it that way. But this is something I'm going to use in my solution. So to find the area like h1, which is the distance between a to this line, so that will be okay, so that would be h1 is equal to, you plug 0 and 0 for x and y. So, but at the same time, if you want to use this approach, your 0 should be alone. So which means my equation is 4x plus 3y minus 19 is 0. So if you plug now 0, 0, because that's the point, and then you are looking for the distance between this point to this line, which is h1. So that will give us 4 times 0 plus 3 times 0 minus 19. As you see, this is going to be a negative number, so we are going to deal with that by taking the actual value of that number and divided by the square root of the square of the coefficient, which is 4 square and 3 square. Okay, so that will be just 0 minus 19, just 19. So that is 19 over just 5. Okay, so that is my h1. If I do the same thing with h2, h2 is 8 comma 0. So that will be 8 times 4. 4 times 8 plus 3 times 0 minus 19 over the 4 square, 3 square. So what just happened is like you plug 0, 0. So like this guy with my coordinates. So I just plug it in that equation for x and y. And then I did the same thing with the other points. So we had the 8 and 0. So if you want to find the distance between this point with this line, which is the same line, you just replace those x and y, okay? So that's what I did. And then you just need to simplify. So that is 32. So plus 0 minus 19. So I guess that is just 13, right? 13 over 5. So now we got the height, so we can just find the area of those two regions, so it shouldn't be a big deal. So this triangle, the AQP, so the shaded area is basically some of those, APQ, APQ, plus BPQ. So BPQ. So ABP, like APQ is just this triangle. So the H1 is 19/5. Okay, so that's 19/5. And the base was PQ, which is 3. Okay, and then you are gonna divide this product by 2. Okay, and then the second triangle is this side, and the base is still 3, and the height is H2, which is 13 over 5. Okay, and then the base is still 3, and divided by 2. So if you just go and add and simplify, so you will get 57/5. Okay, so that will be 57/5 plus 39 divided by 5 and divided by 2, which is going to be divided by 2. Okay, and then that is going to be 87 plus 9 will be, okay, let me check something if I missed that. Actually, no, I didn't miss anything. So yeah, if you add like 30 by 50, which is 80, 89, 96, if you divide it by 2, because that's divided by 2, so that would be 48, right? So I just like to make sure we don't miss anything. So it looks like this is my answer. So you can do this by using similar triangles, but I really need you to kind of keep this in mind. Surely this between a point and line is really useful. Okay, so this is the number 8. So the work that I did is just this much, which is, I guess, fairly enough. Okay, so I hope that was clear, and I'll see you next week.